Hello, let us see how we can implement a inorderly threaded both way threaded binary tree. So what is the thing is given to us, a binary tree will be given, and from that binary tree we'll modify the binary tree and we'll see the threaded binary tree has been constructed. Now assume that 10 is the root node. It contains 20 as its left child, 20 contains 30 as its right child, and it 10 contains 50 as its right child, 50 contains 90 as its right child, 90 contains 100 as its left child, and 15 as its right child. So this is a binary tree. Now we will modify the binary tree and we will get a threaded binary tree. Now if we perform the in order traversal on this binary tree, we'll get the following sequence. It will first print 20, then it will print 30, then 10, then 50, then 100, then 90, then 15. Now here there is a link from 10 to 20, so we'll draw a this edge. 10 also contains 50 as its right child, so there is a edge. Now 20 contains 30 as right child, so there is a edge. Now 50 contains 90 as its right child, 90 contains 100 as left child, and 15 as its right child. So this is given. Now in this binary tree we create a special node with the name header. Now here how to construct the threaded binary tree. Now the node 20 is a special node. It is the first node that occurs in the in order traversal. So the first node will point the header, and the left part of the header will point 20. Similarly 15 is the last node in this in order traversal, that is 15 will point this header node, and the right portion or the right link of the header will contain the address of 15. So these are the first two things that we need to create to construct threaded binary tree. Now consider this node, because this node contains null links. Now this address part, so this address part will contain the address of the in order predecessor of 30. So in order predecessor of 30 is 20, so the address part of left will point to 20. Similarly, as the right child link is null, the right address part will point to the in order successor of 30. So in order successor of 30 is 10, so this will point to 10. So 30 done. Now come to this point, come to this node, as there is a null link. So now 50, what is the in order predecessor of 50? That is 10. So this address part will contain the address of its in-order predecessor. Now consider this note. This portion will point to the in-order predecessor of 100. Who is in-order predecessor? 50. So 100 will point to 50. Now this one. This portion will point to the in-order successor of 100. Who is in-order successor? 30. So 100 will point to 90. Now consider this one, 15. The left link will contain the address of in-order predecessor of 15. Who is in-order predecessor of 15? 90. So 15 will point to 90. That is 15 will point to 90. So we have constructed the in-orderly both way threaded binary tree. So you can see that all the null links are used by some other node to hold the address of some other node. So n+1 null links are used, and we also have included a special header node. Now this header node will help us to perform the in-order traversing, and we'll later see the in-order traversing by using the in-orderly both way threaded binary tree. The stack will not be used. So these are the advantages of threaded binary tree. So if we use in-orderly threaded binary tree, we do not need to use the stack data structure to implement the in-order data structure, in-order traversing. Thank you.